Howdy folks, welcome to week 7 homework. I know this one is a homework where I could really spend a lot of time on some of the subjects, and there really isn't that much necessity to spend a whole lot of time on some of these subjects. This week's homework is important because it's going to cover kind of like the second half of what structural equation modeling is all about. Last week we looked at mediation, moderation, and multiple dependent variables, and really we started looking at path analyses. This week we're covering factor analysis, particularly focusing on exploratory and confirmatory factor analysis. So let's get started. What exactly is factor analysis? Well, the main idea is that with factor analysis you are checking whether a series of variables line up to work as a single factor, single variable. So if you have a survey with 10 questions about happiness, a factor analysis can tell you, do all 10 of those questions seem to all be related to the same thing? Can we explain all of them with a single factor? Those questions, those series of variables are going to be called items whenever we talk about this stuff, and that just makes it easier to separate those two types of variables. Items are the things that make up the things that you measured and that will make up a factor that you're trying to get to or use to explain something else. What is a factor? Well, it can be something real, like technically any variable included in an analysis, like a regression. An independent variable would be a factor in that analysis. It can be an abstract sort of thing. So if you're measuring happiness, happiness would be the factor, but the way that you measure it might be through a series of questions, like 1 to 10, how happy are you? That's one item. Every day, how many times do you think you smile? Every day, how many times you get in a fight? Of course, that last item is going to be backwards or reverse coded from the way the other items would be set up. A factor can also be kind of arbitrary. You don't necessarily have to have a specific, meaningful, theoretical concepts behind what you mean when you're talking about a factor all the time. For example, sometimes a factor is something that you just notice all of these things come together and they mean the same thing. This can kind of be a little bit like red flags. So if you are in a relationship, there's a lot of different things that can signal that maybe there's a problem with the relationship, but they don't necessarily have to be the same things. They don't necessarily have to have anything particular in common. The only thing that they have in common is that together they all kind of suggest the same thing. So factors can be really, there's a lot of different ways that you can come up with your factors, just like there's a lot of different ways you can come up with the variables that you use in an analysis. Now, one thing that's important to note is that factors and factor analysis is a little bit unintuitive. Normally, the variables that you measure, kind of the independent variables, explain another measure or they explain a dependent variable. But in factor analysis, we actually think about them the other way around. So we say that the factors predict or explain the items. So in actuality, while you might be making a questionnaire about happiness, when you run the factor analysis, what's going on is the analysis assumes that there may be some factor called happiness, and it checks, well, how well do each one of those items, how well are each one of the items explained by that other factor? And so, how happy you are could be how many times you smile, how much dopamine's in your mind, whether or not you've eaten today, how many fights you've gotten into today. Again, that last one probably reverse coded, and I realize now it's kind of funny that this is what my head immediately goes to when I think of what is happiness. So it can also be dangerous to do factor analysis sometimes if you don't have a preordained theoretical explanation for why certain factors should be hooked up together, because much like running exploratory analyses, you can come up with a result that is meaningless and then just decide to ascribe meaning to it. I don't know if that's too confusing, but let's move on. We're going to go into the types of factor analysis that we're really going to focus on in psychology. The three of them are going to be reliability analysis. You should already be familiar with that. Do the items come together to explain or to form a single factor? So the more complicated pair of that is confirmatory and exploratory factor analysis. We're going to start with confirmatory factor analysis, which is answering the question, do my items come together into a series of preordained, pre-thought-out factors that I expect or hypothesize? Exploratory is a little bit more complicated because it is going to have a lot more options to it, and it's not going to be as pre-controlled the way exploratory factor analysis works. What it's about is what's the best way to group my items into factors. And so that's really where you can get into trouble if you just dump a bunch of items into an exploratory factor analysis without having any idea of how they should go together. If you just, by luck or chance, you happen to get like 7 different factors and then you start ascribing names to them like you're divining a prophecy, it's not going to be the safest, the most kosher way to run that analysis. Whenever you do any sort of stats, you always want to base yourself on some theory, some preordained, pre-existing hypothesis that you came up with or that someone came up with, so that you're not just fishing in the dark here. So let's do a quick reliability analysis. I know you're supposed to already know this, so I'm not going to spend a whole lot of time on it, but it's helpful to do this because it's going to help us see what exactly the other 2 analyses are doing. So I'm going to start out by going to Jamovi, and we're going to go get the, if you're learning statistics with Jamovi, there's these personality questionnaires here. They come from the Big 5 personality questionnaire. I'm not sure exactly what it is, but it's pretty convenient data. We're going to work with the second personality questionnaire here. So what do we got? We have this series of variables, A1 through 5, C1 through 5, E1 through 5, N1 through 5, O1 through 5. Folks who've taken my class before will be probably tired of this data set. And every one of these letters indicates a factor that things are supposed to be associated with. So A1 through 5 are all questions or groups of questions about agreeableness. Okay, so let's run that reliability analysis. We're going to go to factor, reliability analysis. We're going to pop in all the A items. And yes, whenever we run any sort of factor analysis, we really should be working with continuous variables. And even though they're not set up as continuous, the data lend themselves to the analysis, so Jamovi's okay with it. If you want to fix this, you can go select that. Double click, and then select everything. Shift, pop it into continuous, all set. Right. So we get this Cronbach's alpha of 0.469. A good Cronbach's alpha is 0.7 or greater, and we'll usually have at least 1 or 2 things we can do to improve this. Here it says that A1 should be negatively correlated. We don't have any reason. If you actually run this analysis, you will want to choose which items should be negatively correlated based on what you decided was a reverse coded item. So if you do get this negative correlation stuff, you can choose to change it, but when you choose to do that, make sure that you're doing so purposefully. Make sure you can try and figure out, why does negatively correlating this item improve its reliability, make it work better with the other ones. Maybe it's worded in a funny way, or maybe the item is measuring something that you did not expect it to. So this is one way to notice that your items might be messed up if there's something that it suggests should be reverse coded. When we reverse coded it, we got a better Cronbach's alpha. The next thing that we can do once things have been reverse coded, we can go to Cronbach's alpha if item is dropped. And what this is going to say is, well, here's a bunch of reliability analyses. What happens if we just delete variable A1, reliability goes up, delete variable A2, reliability goes down. So a lot of times what people will do to find the most reliable version of their scales, of their measures, is go, okay, well, we're just going to delete any data that is not really helpful in understanding my A agreeableness factor. So we'll just get rid of A1. Okay, let's check the items if dropped again. We're at 744. Can we improve it at all? By deleting an item, we can't. So we've arrived at our quote-unquote best, most reliable version of our measure, which just did not include item A1. And we've hit a Cronbach's alpha of 7.44. That means that we're pretty well saying that the majority of our items are pretty strongly connected to each other. They're all kind of moving in the same sort of way. Let's now see where that Cronbach's alpha comes from. And in reality, basically what it is the average correlation between all of the variables. So here's what I'm going to do. We're going to go create a new variable. Right here, it's going to be a calculated variable, and we're going to call this mean A 2 through 4. And I'm just going to get the average of A2, A3, A4, and A5. Sorry, I should have put 2 through 5 there because that's what was in our analysis here. And close that parenthesis. So now we get the average score for 2 through 5. And the next thing I'm going to do is run a correlation. Let's see how well our variables here all correlate to each other. And I know we didn't include A1 in there, but we can actually see the correlations, and we're just going to look at this mean 2 through 5 section. A1 correlates negatively and not very strongly, and all the other ones correlate positively and pretty strongly. And so if you average these guys together, let's do a little quick calculator, calculator. Let's see, 0.734, just averaging together the R's for each one of these correlations for the items compared to the mean item. 7.734 plus 0.815 plus 0.709 plus 0.757 divided by 4 gets us 0.753, and that's pretty close to our Cronbach's alpha. That's almost exactly what is happening when the Cronbach's alpha is calculated. You actually divide this by the total amount of variance. That's why the Cronbach's alpha is never going to be the exact mean. It's going to be a little bit smaller than that, but hopefully that gives you an idea. How do we know that these items are all associated to each other? Well, the average correlation between the individual item and the overall average version of that item is pretty good. If I was to put this in more theoretical conceptual terms, I would say that on average, the covariance between any one item and the whole set of items is pretty dang good. Okay, so now we're going to move on. We're going to take a look at confirmatory factor analysis. A couple points about confirmatory CFA is that your significance is going to be backwards in CFA. We actually want a non-significant result. That non-significant result is going to tell us that the model is not significantly different from the actual data. In other words, what we expected to find and what we actually found were not significantly different, and that's good. And we also have an effect size, RMSEA, that is again going to kind of work backwards from how we usually use effect sizes. Usually a larger effect size is better. In this case, a smaller effect size is better. Again, a smaller effect size tells us that there's a lower size difference between our model, the factors that we pre-hypothesized, and the data that we actually have. So usually an RMSEA of less than 0.05 is considered pretty good. The other things that the CFA can do for us is tell us what ways can we improve our model, what ways can we take these items that we've included in certain ways and reorganize them or include them in different places so that the model better explains, or the items are better explaining the factors that we have. And finally, we actually get regression formulas so that we can calculate a factor out of that series of variables. Funny enough, a lot of times what people will do when they run these complicated regressions and stuff is that you can take a
you can take a measure and just, out of my 10 happiness questions, mean the results together. But this is another way of combining those 10 happiness questions, doing a confirmatory factor analysis, getting the estimates for those, and calculating a happiness score based on how well the items relate to each other. Okay, so just talking about it is not really going to give you the best understanding. Let's go through and notice these three things: the significance of the CFA, the modification index, and the regression formula, and just understand what the CFA is going to do for us. So we're going to go to factor and pick the confirmatory factor analysis. It's called a confirmatory factor analysis because you're going to pre-choose what your model looks like. So we're going to have one for a factor that is agreeableness, and we're going to have one that is conscientiousness, and the next one is extraversion, and next is neuroticism, and last we got openness. The order in which you have these does not matter. All that matters is what you have in those boxes. And whoops, I'm accidentally putting the wrong ones in there. Put those where they go. All right, let's try that again. Conscientiousness has these 5. Extroversion has the next 5. Neuroticism, next 5. Openness, next 5. And I can tell you that you're perfectly fine mixing and matching reliability, confirmatory, exploratory factor analysis, but your confirmatory factor analysis is kind of going to do this what you want, or your exploratory factor analysis is going to do what you want. There's not often going to be a reason to do both the reliability and one of these two types of factor analysis. Reliability is just a really, really good, simple, easy thing to do. These ones are going to be a little bit more sophisticated. All right, so it's done the analysis. One really helpful option, you go to options. Is it not in there? Okay, maybe I got myself confused there a little bit, but let's just look at what this table is telling us. You can start off with this graph here. Click on the path diagram. Might take a little moment for it to come up, so let's talk about the graph. Oh, okay. Let's talk about the graph, like what I said, and what the program wants us to do. Come on, spinny thing. Go, go, go. I'll let it finish. Okay, so what do we have here? What we have is, in essence, a series of 1, 2, 3, 4, 5 regressions, each one with our 5 items, and they each get the coefficient estimates just like you would have in the regression. So there's that regression formula I was talking about. So if we want to make a variable called agreeableness, the best way that we can merge all of these variables is to use these estimates. So multiply, 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 add them together, and then you would come up with your overall agreeableness variable. Remember that A1 was negatively associated to the other ones. In this case, it's gone the other way around and said, okay, well, A1 was first. I'm going to say the other ones are negatively associated. And you notice that the magnitude of this estimate is definitely weaker than the magnitude of these other dudes. Besides that information, there really isn't that much else you need to get out of this. Unless you want to use the prediction formula to come up with the aggregate agreeableness variable instead of just averaging your agreeableness items, you don't really need this table. So let's look at the next one. Here we have a kind of a thing that tells us something similar to what we were doing back here. I'm really not too keen on explaining what this is because it's not as useful as this next part. This is where we check the significance of the analysis we just did. So remember, a significant analysis is no bueno. This is telling us that there is a significant difference between the model that we proposed and what we actually have. Over here, our RMSEA, again, we want an RMSEA of 0.05 or less, so this is higher than 0.05, which means we have some trouble here. And here we have the path analysis. This is showing us, okay, well, this is just kind of a visualization of the analysis that we just did. So we have these 1, 2, 3, 4, 5 factors that we preordained, and they come from, or they predict, these 5 sets of 5 items. And it just kind of has assumed that there are correlations between all of these factors. This is kind of what we're going to be looking at, similar to what we might be seeing in some of the SEM stuff that we'll be working with. The last thing that was really helpful here is the modification indices. This is what I mentioned over here, which is the bit of information that can tell us how can we improve the model that we have made, this whole model, still holding on to the same data and items that we've got, but just by messing around with how we've organized our items. So what this is doing is it's telling us that in the agreeableness factor, there are some items from other factors that might belong in with this agreeableness factor. So remember that this stuff was not significant. The way that it checks for significance is with a chi-square, and what these modification indices are telling me is that if we included item C1 in the agreeableness factor, chi-square would go up by 4.216. So right now it's 739. We're going to include that C1 in there, and it should go up to, about 743. We're going to include it in there. It'll take a little second to figure itself out again. Thinking about it. Okay, there you go. So now you see it's been included in this list. It's no longer included in there. And then we have 735. So it made that improvement that we talked about. Now, why are these red? You can choose how much of an improvement is important to you. So if you only want a minimum improvement of 20 in your chi-square, you can set that, and it's just going to re-highlight just the ones that improve your confirmatory factor model by at least 20. So it's not doing anything fancy there. It's just saying, okay, well, if you do this, you do that, you do that, it'll be better. And the higher this chi-square goes, the less significant things are going to be, the better their model's going to be, the more accurate, the more effective, I guess, the closer to good your items can be. But just again, be aware that if you just willy-nilly mess with your model here, just based on these modification indices, you're not really thinking about the theory behind what you're doing. So if you look at these numbers, you might consider, well, why might extroversion 4 question actually be associated to agreeableness? That's interesting. I'm not sure. Okay, so that's pretty much everything for the confirmatory factor analysis. The last thing we're going to look at is not the exploratory, it's the exploratory factor analysis. It's going to do pretty much all the same stuff that the confirmatory factor analysis did, except it won't have the modification indices because it's already going to try and pop everything into the best place that it belongs. And instead, it's going to have a couple assumptions that we need to check, and we'll be able to check how the model was come up. How did the computer decide this set of variables belongs here and this set of variables belongs here, and we have a total of 3 factors out of 20 questions. Let's go ahead and run it. Go to Factor, Exploratory Factor Analysis. We're going to again pop in all of our variables. We're going to not include this funky one that we made up. So this is again the same list of A, C, E, and O. And it has come up with 1, 2, 3, 4, 5 factors. And the order of the factors is telling us the strength of the association between the items in the factor and the factor itself. So our strongest factor, our most reliable factor is the neuroticism one. Its coefficients are pretty strong. Next up, conscientiousness, and next up, extroversion, and we're starting to see that things are getting a little bit shaky here towards the weaker factors, towards the weaker latent variables. These are called latent variables because the analysis looked for how many factors the data suggests or exists, how many factors exist latently in your data already, so they can also be called latent factors. And so when it did that, it said, yeah, extroversion questions 1 through 5 belong in a factor together, but also maybe we should put neuroticism in there. And so here's kind of like its version of the modification indices. If we go back and look at the extroversion factor and check neuroticism, I bet you it would have a bit of an improvement. So we find extroversion, check out neuroticism 4, and there you go. It's got a pretty high modification index, telling us that maybe neuroticism goes into extroversion, and the exploratory factor analysis, in fact, guessed, assumed, figured out that it belongs in there, so it popped it in there. Now, one thing about exploratory and confirmatory factor analysis is that you generally do not want any item to work for 2 or more factors. You usually want your items to be monogamous. And that's kind of because any overlap between the two introduces sort of a haziness to the variables. It introduces some concern about how things should work in your factor. So part of what an exploratory factor analysis is going to do is it will always include something called a rotation. You really don't need to know what a rotation is in a lot of depth. This is as much as you want to know. What a rotation does is it encourages your items to be monogamous, to only be associated to one factor. There are many types of rotation. Oblimin or oblique rotations, those are the same thing, is the one that we use in psychology most of the time, and it's default here in Jamovi, because Jamovi is kind of made for social scientists. So that's pretty cool. The last thing I wanted to point out here is, well, let's do 2 more things. Earlier I was looking for this, sort loadings by size. And so all this does is it organizes this chart into a nice little easy way to see, okay, well, the neuroticism goes first, and down here we got the weakest factor, up here we have the strongest. The other thing that we can do is notice that this says hide loadings below 3. So if we put that at 0.0001, we'll see what this chart actually is doing, what the exploratory factor analysis is actually doing. It's actually doing a check, a correlation for every item, for every factor, and seeing, okay, well, are they good? And so like the useless ones, something that's really weak or negative, it just ignores it by default. It doesn't even show you it by default. So if we put this back at 0.3, you'll notice what we had before, it just ignores the correlation that was here because that correlation sucked. Sorry, N1, you don't belong in factor 2, you belong with factors with the other items, the other N items. Okay, so we saw just now how the exploratory factor analysis decides which items go in which factors by just looking at how strongly are they correlated with the factors. But how does the exploratory factor analysis decide how many factors, how many latent variables you should have? What it does is it looks at the eigenvalues of your data based on the quantity of factors. Now that's a kind of iffy thing because it involves the phrase eigenvalues and a lot of other confusing ideas. Let's just look at this thing. It's called a scree plot, and it'll make it a lot easier to explain what's going on. I'm not going to go into this in a whole lot of detail. Basically what we have on this graph, this yellow line is the simulated amount of variance accounted for based on completely random data for 1 through 25 latent variable models. So right now we have 5 latent variables, and this is the line that says, well, if our data were completely random and we had 5 latent variables, this is how well our variance should be accounted for. This blue line is telling us how well our variance was actually accounted for based on the number of factors in the model. And so because with 5 factors we are doing better than random, and with 6 factors we're doing worse than random, the model has decided that the best way to operationalize this set of 25 items is a set of 1, 2, 3, 4, 5 factors. You'll notice that the first factor has the most variance accounted for, in the same way that here this first factor is really strong, and these later factors down here are getting weaker and more confused because down here we have weaker and more confused factor loadings. You can even tell that things are kind of funky because the first and second factors are way better than the last 3. And first and second factors are way better than the last 3 because these dudes have these extra ones in there, and they have kind of weird things that don't belong in there because they're a little bit more hazy than these factors. I hope that makes sense to you. When we run our SEM, we're basically going to be doing a confirmatory factor analysis. But before we do that, you may wish to run an exploratory factor analysis just to check that our data actually fits the factors that you think they're supposed to fit. I know some folks have already done that. Hooray for them. But if we have time, we will do that in class on March 3rd together, so that we'll get an idea of how well or how poorly your items map onto your factors that you decided. So that's going to be it for this time. We're not too far past the 30-minute mark, so thank you for listening. I hope you have a great day, and I hope the homework for this ain't too bad. Take it easy, y'all.